Yep, and we're live. So thanks again for joining, guys. So this is Get Going with KTS, Get Going with Kubernetes. This is our intro call, and um, so I'll just go ahead and share my screen, and I'll be asking us some questions. And please feel free to ask me questions along the line or at the end of my presentation. So I'll share my screen in a sec. Please let me know when you do see my screen. Yep. So can you see my screen? Please let me know what you see.
Coming up.
Yes, who am I? I can see who am I.
All right. So now, get going with Kubernetes. Yep. So this is so I recently I put up a tweet to ask people if they'll be interested in learning Kubernetes, and I got a few people interested who reached out to me. Some people reached out via DM. Some people indicated via the form that I put on Twitter, and I felt okay. We could do this. Yeah, makes sense. So this is Get Going with Kubernetes, just to help people who are starting out in cloud native, in Kubernetes, in containerization, to help them, like the word says, get going, get familiar with it, just have a relationship with Kubernetes, basically. And that's what we're doing here. So who am I? So my name is Illyria Yoadebi. You could call me Illyri for short. And I'm a cloud native engineer at Container Solutions. Container Solutions is a cloud native consultancy, right? So we help companies transform into cloud native, basically, long and short of that. And also, I'm a preacher, right? I preach the gospel when I'm not doing tech. Basically, you find me in church or you find me preaching to people. Yep, so that's about me. Now, the objective, like I said earlier on, is to get us or get people going with Kubernetes. So I've been using Kubernetes for I think since 2019 or 2020. I cannot accurately remember. And first time I started using Kubernetes, I didn't understand the basics. I didn't understand the fundamentals. And it was a cool technology because I already was familiar with containers and containerization. But I started using a tool for Kubernetes, which is Rancher, and that simplified things a lot. It was easy for me to get a cluster up and running, with just a few shell scripts and all of that. And it was just so there was a whole lot of things I didn't get to understand at the time, at the moment. All right. And I began to explore, began to study. It was a complex system, actually, and I'm still studying. Of course, Kubernetes is changing. Every year, every few months, there's a new release, and so I just felt I could help people start this journey because I've heard a lot of people talk about Kubernetes and they don't want to. They're building good systems. They're building massive systems, but when you talk about Kubernetes, they are like, I want to learn about it, but it's too much work and all of those things. And so I felt this is a good opportunity. So, like I said, I'm a cloud native engineer. So one of the tools that we work with where I work is Kubernetes. Yep. So this sort of program, you can call it a program, you can call it I don't know what to call it, but Get Going with Kubernetes is supposed to help you learn Kubernetes by one, reading a book on Kubernetes. All right. So I recently started reading a book called Kubernetes Up and Running. I wanted to see how, I was reading another book. Okay, let me just allow. Okay, so I see somebody just joined us. Etsy, right? Oh no, I don't see him anymore. All right, so it's we're going to be reading a book. Okay. The book is I think there's a free version online. I shared that on Slack. Okay, I see Etsy now. Hey Etsy, can you hear me?
Yeah, I can.
Oh, all right. Good to have you. So I was just running through what the program is about, running through what we're doing here, what this is all about. So thanks for joining. So I said that the mode of operation or the modus operandi for this program, all right, is to help is we're going to go through these three things: book reading, workshops, and peer collaboration. So the first thing is that we have a book that we're going to be reading. It's a recommended book, all right, in the community, in the Kubernetes community. It's called Kubernetes Up and Running, and it's a really nice book. It gives you the basics of Kubernetes. It gives you the fundamentals, and it was written by some of the people that built Kubernetes originally, right? Kelsey Hightower, I think Joe was part of them, and Brendan Bones or something like that. I cannot remember their names, but that book is a really good book. Some of the things there are not as accurate as, because Kubernetes is a changing technology. It's one of the most active technologies on GitHub. So there's a lot of contributions, a lot of changes and all of that on Kubernetes. So if you write a book of Kubernetes today, you will need to review that book next year or next years. So even though we have that kind of change in the Kubernetes ecosystem, but this book is still a highly recommended book, Kubernetes Up and Running. All right, I'll share the link afterwards again on Slack, but I know I shared that before. Then the second thing is that we're going to be having workshops. All right, and those workshops are practical sessions where we'll actually get our hands dirty. We're going to write the YAML, we're going to spin up a cluster, we're going to deploy applications, we're going to check how replication works, we're going to check how controllers work and all of those things. And yeah, we're going to have those sessions, but it will not be anchored solely by me. All right, so we're going to have a mob kind of a mob programming style of approach. And what that means is that we're going to have the same way, just like we have pair programming, where two people are working on the same code base, but they're working from one computer. All right, so both of them are looking at the computer, they are making changes. All right, so one person is driving, the other person is giving his input or their input, and right, then after a while they switch, the other person takes over the driver's seat, and the other person is contributing, making recommendations and all of those things. So we're going to have that kind of approach. And what that means, it's called mob programming. What that means is that one of us at every given time will, hey, welcome Edmond. If you're here, if you can hear me, thanks for joining. I don't see him. All right, so one of us is going to drive as we go along. So it could be me, it could be somebody else, but the idea behind that is that we want people to have practical experience. So you're going to actually put Kubernetes on your computer, you're going to deploy something on your computer, you're going to have code on your computer, then the other people would watch, the other people would contribute. And so that's how it's going to be like. So that's called mob programming. Then the final thing, the third thing, or the third way that we're going to learn is through pair collaboration. All right, so I went ahead to create a Slack channel on the CNCF Slack workspace. All right, I'll talk about CNCF in a bit. So I went ahead to create a channel there. Okay, I cannot share that right now, but yep, we have a workspace that we're using on Slack. If you're not familiar with Slack, Slack is a collaboration tool. You have WhatsApp, for instance, where you chat with people. So, but Slack is a more professional tool for collaboration amongst engineers, software engineers, cloud engineers, and tech people, basically. So we're using Slack. We have a channel there called Going With Kubernetes. There's been some interactions within the last 1 week since we started. So we're going to have on that channel people asking questions, people answering questions. I found that to be a very good way to learn, right? When you have people in a community and they share the same goal, they have the same vision, and they are working together to achieve that goal. All right. So that's what Slack is going to be there for. So, for instance, you're reading the book and you're on chapter 2 and something is unclear, you could just come on Slack and put a question there, and somebody else who is reading chapter 2 or has gone beyond chapter 2 can just respond. All right. So everybody's working together. Then when we get to the workshop, we look at everything practically. We bring our questions together. Somebody is doing the real coding. And of course, from the input I got from the Google form that I shared about 3 weeks ago, not everybody has a computer. Now, that is not okay. So if you want to be here, you're supposed to have a computer where you can run these things. But I saw that not everybody has a computer. So that workshop will be yeah, so somebody else is joining. So that workshop is going to help people see when you're reading the book now, you want to see it in practical. You can see it from somebody doing it on their own computer, and you can ask questions. So it's going to be real time. All right. The are going to be real time, while Slack is going to be asynchronous. All right. Then, yep, that's the mode that we're going to be running. Then now, let's enter Kubernetes. I'm sorry, I don't have too many slides. I just have 7 slides, but of course, I can share I can share. This was not supposed to be a full hands-on session. It was just supposed to be an introductory session. But let me I'll share another screen. So, brief introduction to Kubernetes: what, why, and how. So of course we have Gideon here, we have Deepo here, they're my colleagues at work, and please feel free to chime in at any time if you have something. Of course, I'm sure you have things. So Deepo here, if you can hear me clearly, Deepo here is certified, is a certified Kubernetes administrator. That means he has done the Kubernetes exam and he has passed the exam. All right, so feel free to ask him any question. That's Deepo. Then Gideon here is also my colleague and is well versed with Kubernetes and other cloud native technologies. So please, if you guys have anything to share along the line, please go ahead. All right, so I'll just give us I said introduction to Kubernetes, the what, why, and how. Now, my explanation will be a bit crude and basic because like I said earlier, from the survey, after looking at the form, I found that a lot of people that said they wanted to learn Kubernetes have very basic understanding of even containerization. All right, not to talk of Kubernetes. And Kubernetes is built on containerization. So I'm going to start from there. Let me explain containerization. Now, okay, quick poll from those of us on the call, besides the people that I've introduced already. So we have Etsy, we have Larry, we have Onyi. So do you just want to quickly share, your experience, what experience you have in software engineering or cloud engineering? Let's just get an idea of who we are. Please, who wants to break the ice? Anybody?
All right, I'll start first. Can you hear me?
Yep. Loud and clear.
All right. So I'm Ijama, and I'm a backend developer. Yet, majorly I use Node.js and Python for my backend. I done a bit of I use Docker to daily, and I have like a very little understanding of Kubernetes. Sometime last year, by so yeah, that's
Nice. Thank you, Ijoma. So from what I heard, said you're a backend engineer, a Node.js backend engineer, and you have some idea of, or you use Docker. All right. So like that means you're familiar with containerization. All right. Thank you so much.
Yeah, you're welcome.
All right. So does Edmond want to go next, or Larry, or Wayne? Feel free.
Okay, good afternoon.
Yeah.
I don't know if my own will be nice anyways. My name is Larry. And okay, I work as a tech support. I use cloud tools majorly, like maybe Azure and AWS. I'm a bit familiar with some of the cloud technologies and their tools, EC2, VM, some of all of those tools out of work. I also understand the Linux, so maybe more than a beginner, like maybe an intermediate expert. I've not really worked with Kubernetes professionally. I've just watched one or two videos just to understand what Kubernetes is and containerization for myself. So Docker, Kubernetes, I've not really worked with them. I've just maybe it's not like I don't have an idea of what well, I've not really worked with them, so I don't know if that works. So I'm totally a beginner when it comes to containerization. I'm just familiar with Linux systems,
All right.
cloud
Thank you for that.
technology.
Okay. Cool. Cool. Thanks. So who wants to go next? Edmond, Oyin, feel free.
Hello, can you hear me?
Yes, loud and clear.
Okay. Hello everyone, I'm Onidamala. I'm a backend developer and I have less than a year experience. So I've worked with Docker and Kubernetes before once, but I didn't on it to have like a very thorough understanding. I just used it for a project, so I can say I'm a beginner as well.
All right. Thank you. Are you a software engineer, cloud engineer?
A backend developer. I use Node.js and Python.
All right. Awesome. Thank you. Then the last person, Edmond. Do you want to fire
Yeah, good
in?
afternoon. Good, yeah, good afternoon, everyone. Can anyone hear me?
Yes, sure.
All right, good afternoon, everyone. My name is Edmond. Though I've not used Kubernetes before, or computerization before. Conta,
Containerization.
but I'm a front-end developer. I write React.js and a little of Node.js as a backend. Thank you very much.
Right. Thanks, Edmond. I'm just going to mute you. All right. Yep. So thank you for all of that. So let's move into Kubernetes, the what, the why, and how. Like I said, Kubernetes was built on with the principles of containerization in mind. Now, so what do we mean by containerization? So we're developers, most of us are developers, yeah, and we write code, Python, Node.js, front-end React, whatever we write. When you want to, let me use my experience, all right? So some time ago, I was writing code, at this company, and it was just on my local host. When you run your code and you go to localhost colon 3000 or 5000 for Python, and you just have the code running there, or you for a backend engineer, you test with Postman and all of that. That was my experience, and I didn't really understand at that time. I was trying to understand what production meant. When you say production, we're going live, all of those things were intriguing. I wanted to really see what it meant. When you say that a software is live and it's running and, all of those things. And you read stories, read Netflix, you read Google, and you see that they're having heavy systems in production. And you see that word come up again and again and again and again. So I was curious to find out what exactly is production. And it turned out that production is, now mark my words, or let me choose my words carefully. Production is more like your local host. All right, you have a software that is running on your local host. Maybe you did for, I think we have a lot of Node.js here. Maybe you did npm start and it's running. That's how production looks like. All right, you go on the server. All right, the server is like your laptop, but you do the same thing that you do npm install. For Python developers, you do maybe pip install, and you install all the requirements for your application. Then you do npm start, or you do Python main.py, something like that, and your application is running. So it turned out that that's what production actually is, but it's a different computer, a computer that is more powerful than yours, and a computer that is always available. For instance, when you're coding on your computer at night, you probably just close the lid of your computer or you shut down your computer. But this computer, this heavy computer, is not going to sleep. It's always online. It's connected to the internet, so that whenever people try to access your application, it's always available. So it began to make a lot of sense to me at that time. Then I ran into issues. Now I began to deploy applications for people. All right. And when I say deploy, I mean I'm taking it from their computer or from GitHub or from Bitbucket, where it is, and I'm doing what they will do on their computer. I'm doing it on the server at the time. So say somebody makes an update and they push a new version of their code to GitHub. Then I take that code and I go to the server and I do git clone. That was me back then. I do git clone and I do npm install, or I do pip install, and I begin to run the application on the server. It became, I got some issues along the way where it turned out that the developer was running a different Node version or a different Python version, and the server had another version, a different kind of version. And there was a lot of conflicts. So we got that issue where it was working on the developer's machine, but it was not working on production. It was not working on the server. So that's where I was. And back in 2017, I was learning about Docker, all right, at some meetups at Andela back then. And I saw that, oh, this is a nice tool. This makes a lot of sense. And so when I got into containerization, I now saw that containerization would solve many of the problems that I was facing at that time. So say somebody works on their laptop, they're doing Node.js or React or Python, and they build an application. Rather than taking the code alone, all right, I'm taking a picture or a snapshot of their computer and I'm replicating that on the server, all right? So in other words, I'm packaging the application with its environment, with its requirements. So if you're using a Core i7 and on that Core i7, you install Node, you install npm, whatever you install that makes your application run, all right? You install all the requirements for your application, and note, the requirements also include that you're creating.
I don't know if it's just from my end, but you're breaking.
Pardon?
I said, I don't know if it's just from my end, but you're breaking. I don't know if any other person can.
Oh, okay. Can everybody hear me clearly?
Yeah, I can.
Yeah, we can hear you.
Okay.
It's probably on
Yes,
I think it's Larry.
yes, I can hear you. I hear you clearly.
All right, cool. So I think it's Larry's network. But don't worry, this is being recorded, so you can have a look at it later. All right, so I said that, so you're taking, containerization is you're taking the application with its requirements. You're packaging all of those things together. All right, let me use the example that Kelsey Hightower is one of the guys that helped build Kubernetes. Well, not build per se, but it was one of the guys that evangelized Kubernetes at the start. Right, so he said that imagine you have a letter. All right, you want to send that letter from Lagos to the US, for instance. Now, we don't use letters here that much in Africa, well, but so it might not be a good example. But what you do is you take it to the post office. The post office would put the sender information, they'll put the receiver information, they'll put every detail, they'll package it together and they'll probably put it in a box. All right. So the application moves from Lagos, or it moves from your place to the post office through the ocean or through the airway or whatever, means of transportation, and it gets to the person's place. All right. Exactly as you sent it. All right. So there are no issues. It's boxed, it's packaged. All right. So that's a similar analogy to what containerization is. Now, you package your application with its requirements and the operating system that you're using. For instance, some applications will not run on Windows, but they won't run on Linux. So it means that when you're deploying that, you need to, on your server, you need to ensure that you have Linux running. But in this sense now, containerization is saying you don't need to bother about the server. You can package all that is required for the application in a single image. All right, just a snapshot of your system, the way your application runs on your system, and you take it and you put it on the computer or on the server, and it runs out of the box, just the way it runs on your computer. So that issue of is running on developer's machine, is not running on production, it's not running on the server, that issue is being taken care of. All right, so that's one of the benefits of containerization, and that's a short or a very crude way to explain containerization. Now, another thing that containerization solves is, so say you want to deploy, for me, and I remember I've had a conversation with Ope. Ope is also my colleague at work. All right. And so I remember there were times where, you have maybe like $5 and you just get this server from DigitalOcean and you want to deploy your Node.js app, you want to deploy your Python app, you want to deploy your React app, everything on that box, on that same computer, on that same server, pardon me. And, you don't want to spend money getting multiple servers. But when you begin to install for instance, if it's a Node.js app, you install maybe Node version 14. That's what your React app needs. Then you now see that the backend Node.js app needs another version of Node to run. You start having issues. Okay, so there some people build something called Node Version Manager that can help you run different versions of Node on the same machine. Okay, so you get that, you now begin to switch. When you want to run your Node.js app, you switch version of Node. When you want to run your React app, you switch the version of Node. But you can't have both of them running side by side, right? So that now becomes an issue. So what that is called is file system pollution. All right, your computer has been polluted, or your server. Now, when I say computer, yeah, I'm saying your server. Your server has been polluted. All right, there's a lot of things that you have installed. You don't even know what you installed, and something is breaking somewhere, something is crashing somewhere. So containerization helps you to, avoid polluting your file system. Since you can have a single image that has all the requirements for your app, you take that one and you put it on the computer. It's running all by itself. It's not polluting your computer. It's not polluting your server. It's not affecting anything that you have installed on your server. All right. It's just using the CPU and the memory of your server. That's it. Then you can now take another image of the other app that needs another version, and you package everything together, and you bring it onto the same server, and you have both of them running. Now, they are running, independent of each other. So that's another thing that containerization does for you. So over time, containers solved problems that people were having, those kind of problems that people were having. There are other use cases for containerization, but that's one good, or those are two good explanations. Now, it helps you ship your software, seamlessly. That's what containerization does for you in our instance. Now, Kubernetes came, and what was Kubernetes proposing? What did they come to solve? So say you have 100 containers. Now, I've not explained, I've been saying image, I've been saying containers. There are differences actually, but maybe I'll explain that later on. But Kubernetes came and said that now you have 100 applications. Now, containers, when I say applications, I'm saying containers. You have 100 applications running on your server. But how do you manage all of them? How do you coordinate between each container? So say you have one React app that's running another Node.js app that's running, another Python app running, all of them. How do you manage those things? For instance, if you've ever deployed an application, you notice that an application is failing. The code that you wrote is failing. Of course, we will always have bugs, but if you are on your computer, what you do is you just check the logs, the error logs. You go to your terminal, you see why it's failing. For front-end engineers, you go to the console, you see why it's failing, or you could just check the terminal. If you're using a more sophisticated framework for the front end, you check the terminal and you see the errors. All right. Now that's good for one application, but when you have thousands of applications or hundreds of applications, that begins to become a problem for you, and you cannot manage all of those things easily. So Kubernetes came along, and they said that they're going to help with orchestrating your system. All right. So now the word orchestrating or orchestra, it's synonymous to the musical orchestra, where you have somebody playing the saxophone, somebody playing the violin, somebody playing, different people playing different instruments. And you have somebody who is coordinating the flow of the music. This person knows when it's supposed to play, that person knows when it's supposed to play. So there's one person in the middle that's coordinating the entire flow. All right. So that's how Kubernetes, is for your applications, for your containers. So Kubernetes is helping you manage the entire cluster of applications, thousands, hundreds of applications, and perhaps hundreds of thousands of applications. And yeah, big companies, they benefit from Kubernetes in that way. So that's how Kubernetes came along, and they said they're going to solve that problem for you. Okay, before I go further, does anybody have any question, or does Gideon, Dipo, Ope, anybody want to say anything in addition to all of this? Please take it away. Anybody?
I definitely don't have anything to add. It's pretty much I don't know, is my fan disturbing?
No, Google Meet has done a great job.
Okay, so it's pretty much the beginning to Kubernetes. I mean, if you want to do Kubernetes is just like a big thing on top of a small thing, so to say, in quotes. So it's big because a lot of people use the underlining thing that is being explained here, which is the container. So before you can actually say you want to do Kubernetes, you must have a very grain knowledge in containerization and stuff. So which is a very good entry point to understanding what Kubernetes is and stuff. So yeah, it's a good start off, I would say.
All right. Thanks for that. Does anybody else want to add something? Anybody else?
Okay. Hello, everyone.
Yeah.
Sorry, I don't know what's wrong with my video. It's not coming up. But what I just had is for what Leah said. I just had a bit thing in containerization and Kubernetes really, how it helps. Like Larry said, it's more of an orchestration tool. Now, when you say an orchestration, right? The first thing that comes to mind for me when you talk about orchestration is like an orchestra, right? Where you have multiple musical instruments, or people playing multiple musical instruments, trying to produce a sound, trying to have an end goal. But they always have one person in front of them that tells, oh, you go, like that. Like there's always somebody in front of a stick, right, and waving it around. So that's what Kubernetes is. It's an orchestration tool for containers, right? So what it's really doing is, instead of me, if we kind of understand, so to backtrack a little bit, when it comes to building, I think one very important thing we need to also mention is the microservice architecture. The major thing we do, or what a lot of people are used to, is the 3-tier monolith application, where you have the front end, you have the back end, and then you have the database. So you're just running a front end, put it on the server. If there's problem, or maybe the memory is finished, you increase the size of your VM. Do the same thing, and that has been what has been running for a very long time, like for a very, very long time. But when when the microservice architecture came in place, what they were trying to do is they were trying to do a couple of things, which was one was build fast. The second thing was being able to have multiple teams managing a particular aspect of an application. So what happened was, instead of you building your application as a monolith, yeah, we modularized and made it into multiple services. So I can come and say, oh, I'm in charge of. So for something that we are all familiar with, let's say I'm in charge of the auth service, so authentication and everything, I'm in charge of it. Maybe Ileri is in charge of communication or chat service. So instead of everything to be in a monolith app, we separated it. So the question was now, how do we manage this? How do we manage the deployment and all of that, right? Since we already separated them into multiple things. That was how microservices was born and what it was for. So now imagine we say, okay, we want to build our applications and we want to be able to scale. And we are also looking at costs, which is another aspect that a microservice architecture is supposed to help us solve, reducing the cost of our infrastructure. So when, for example, we've already built our application, and okay, to backtrack a little bit again, in the last 10 years, or maybe 10 years, 11 years ago, or for very big enterprises, what they do when they start when they want to look at the cost of an infrastructure is they look at what is the highest traffic we are going to be getting. So, for example, let's use Facebook, for example, and say, what is the highest number of users we would have at the time, right? And we say, okay, let's assume that we would have 1 billion users at the time. That's an example at the time. What they do is they buy that server, the server that would accommodate all of that and start using it. But what that had cost was a lot of money was being wasted because most of the time the CPU usage maybe doesn't even pass 2%, right? So one of the things that microservice tried to solve was, all right, if only 2% of our CPU is being used, what happens to the rest of, like, for the most part, what happens to the remaining 90%? That means they're wasting money, right? That's what came in as that was one of the things that factored into having microservice architecture, and now containerization also became a thing, right? Now, the question was now, all right, okay, we agree with you. You don't want to waste money, which is fine, which every executive will to agree with, I believe. That I don't want to waste money. But it brought off another question, which was, how do we manage when we now have this spike in requests or users using our application, right? We need a way to be able to manage that without incurring so much cost. That is one of the things Kubernetes also solves to some extent, which is I have 5 services running at the moment. We are not running everything in one VM. How do we make sure that they are all working together and they can all communicate with each other well? And when there's spike in traffic, for example, we can scale out. And when the spike reduces, we scale back down to reduce costs. So that's one of the things Kubernetes does for us, which is making sure that we can take all those images, because like Larry said, the application, you are going to build it as an image. Take all those images that have been built separately and try to deploy them, because there's an overhead. So if you worked as maybe deployed something before that had to do a lot of services, you understand that there's a major overhead in managing all of them. Like, it's it can be very daunting sometimes when there are a lot. If it's just 1 or 2, you'll be fine. But when you're looking at 5, then you know that there's an overhead. And Kubernetes comes in to try to solve that, which is it tries to make sure that all of these things are working fine. All the engineer or all the DevOps or the SRE or the cloud engineer needs to do is create a YAML file, put some specifications there, and Kubernetes takes in everything and handles it for us, right? So that's one of the things Kubernetes does for us. It makes the life of engineers a lot easier. Like, let me put it that way. It makes the life of engineers a lot easier when it comes to managing infrastructure or workloads, like we call it. Usually we call an application that deployed a workload. Managing the workloads properly and making sure that we don't really need to think about um, so many things at once, and we can focus on other things, right? So that's one of the major things it solves. There are a lot of other things, but I just wanted, since this is more like an introduction, I just wanted to add that to it.
Yeah, very Deeper raised some great points, and I'd like to touch on one of the things he said. So he talked about microservices. All right. So if we're familiar with microservices, Kubernetes it works very good with the microservices architecture. All right. And I'm familiar, I think the last job I had, we were working on even micro front ends. All right. So you have microservices for backends, but now there's also the thing called micro front ends. All right. So Kubernetes helps you with that kind of architecture. It just works well. All right. It's like bread and butter. Yep. So because we're supposed to wrap up in the next 12 minutes. So let's just quickly have a look at Kubernetes architecture. All right. So I'm going to be, can you see, I've changed what I'm sharing now. I hope we can all see this.
Yeah.
How is my screen? Yeah. All right. So let's just quickly do a brief explanation of Kubernetes architecture. So Kubernetes is a software. All right. It's a software that was written by people. Many of the technologies that we use, they are softwares. All right. AWS, what we call AWS, is majorly, relevant because of its software. It's what you interact with the API and all of those things. Even though there's the hardware behind, all right, that the servers, physical cables behind. But Kubernetes itself is a software. It was written in Golang, all right. But now it's more than just the normal software because, like somebody said, it's a platform for other platforms, all right. And I put a tweet out some days ago. I said that Kubernetes is slowly becoming the operating system of the cloud. Just like you have Linux. Linux is an operating system, but it's also a software. It was written, with a programming language. But on Linux, you have other things that are built on it. That's the way Kubernetes is slowly becoming, right? It's becoming like a platform on its own, and it already is. So let's explain Kubernetes. So say you have this black box. This is Kubernetes, all right? Let's just call this, let's just call this Kubernetes. So many times you hear KTS. KTS is Kubernetes actually. The 8 in the middle just refers to the other letters that you take away from Kubernetes. All right, so that's what KTS means. Let's assume this is Kubernetes. Inside this software, all right, you have something called the control plane. Pardon me. Yeah, you have something called the control plane. You have something else called a data plane. Now, it's one system, all right, but there's some kind of separation, even though it's one system. So the control plane is responsible for the administrative activities in Kubernetes. Now, what do I mean by administrative activities? So, just like we have the orchestra, all right, you have one person that is directing the flow of the music. All right, that's what the control plane looks like. The control plane is like the one that is directing the flow. All right, then the people that are actually playing the sound, the people that are actually giving you the music, they are like the data plane. All right, so the control plane directs how things goes, and the data plane is what actually executes that instruction. So on the data plane, that's where you have your Node.js app, for instance. Your Node.js is running on this app, your Python is running on this on this control plane. Your application basically is running on this data plane, pardon me. All right. So the control plane is what gives the instructions to the data plane, and data plane carries out those instructions. Now, inside this control plane, you have several components. All right. Let me just see if I can. I'll share the link to all of these things with us. But let me share another page with us, which will make some sense. Okay, before I share that, let me just go ahead and share that here. So now look at this picture. All right. So you have here this thing called Kubernetes master. All right, that's your control plane. Then you have these other two things, worker 1 and worker 2. That's where your data plane is residing. All right, so just take the same example that I explained with this initial drawing. All right, this initial drawing, and bring it to this picture. You have the control plane, which here is called the master. Then you have data plane, which is called the workers. All right, so now in your control plane, how does the control plane carry out its activities? There are several components in it. Remember, this is just software. All right, it's not physical things that you touch somewhere. It's software. Now you have something called the API server. I hope we can see it. Can I just get like a feedback, because I cannot see our faces? Can somebody just say something? I hope you can hear me.
Yes, I can hear you.
Yes, I can, and I
Yeah, we can hear you.
All right, cool. Thank you so much. So you have the API server. This thing, let me just expand.
Someone is raising up.
Oh, okay. Please go ahead. Edmond, yeah. You have a question. You're muted though if you have a question. But if you don't have any question, okay, I'll just carry on. Just feel free to interrupt me as I explain. All right. So you have the API server, and you have the scheduler, you have etcd. I'll explain what these things do. You have the controller as well. Now, the API server is, the same way you write an API as a developer, you write an API, all right? And when somebody wants to, for instance, if you write a login API, many of us are backend engineers, and when you have a login API, for instance, when somebody wants to log in, what you do is you call that API, you supply some parameters, maybe the username, the password, and all of those things. So the API is the interface that people, interact with. They don't go to your database, all right, to log in. They don't go there. If they want to log in, they will interact with your login API. Your login API does all the checking. It checks the database to see whether this user exists, and all those things. So you have that same thing called the API server in the master, in the Kubernetes control plane. Now, that API server is responsible for all, interactions. So you want to interact with Kubernetes. Now, Kubernetes as a whole, look at this picture again, this thing again, this black box is Kubernetes. You want to interact with this entire black box. The way to this black box is through the API server. All right, that's the way into the black box. So when people say Kubernetes, they are talking about a single unit, but we know that Kubernetes has multiple components. And when somebody wants to interact with a Kubernetes cluster, for instance, it's through this API server. All right, so that's what the API server does. Now, how do you find, or how does Kubernetes, like any other software, you have database where you store information about things. All right, so how does Kubernetes store information about the cluster? How does Kubernetes know that this app is supposed to be running? How does Kubernetes know that you need to have 100 copies of your Node.js app running at a single time? How does Kubernetes know that, oh, I need to, like Deepo explained, there's something called scaling up, scaling down. How does Kubernetes know that this app is supposed to be scaled up? There's supposed to be some information stored somewhere. Now, that's called the etcd store. This etcd, it's called etcd. All right, it's a data store. It stores the state of your cluster, your Kubernetes cluster. All right, just look at it as a database. Now, you have something called the scheduler. All right, this scheduler, it's responsible for, so say you want to deploy your Node.js app into your Kubernetes cluster. All right, what is going to do that? You interact through, remember, all interactions, all external interactions, all right, and even internal interactions. Look at these arrows. All right, it's via the API server, or like this picture calls it the Cube API server, or the Kubernetes API server. So you interact with the API server to deploy an application. But the API server doesn't just go ahead to deploy that application. It talks with the scheduler. All right, the scheduler is the one that now says, oh, the user wants to deploy 2 copies of this Node.js version 1 application. Then the scheduler now goes ahead to do its thing and looks for it just checks if the conditions are right, and it places, there's a scheduling algorithm, all right, that your scheduler could be using, and it says, okay, I want to deploy this application on this particular server. I want to deploy it on this particular node. All right, so that's just what the scheduler does. Now you have the controller. This one is a bit vast, all right, because you have more than, in a Kubernetes control plane, you have more than one controller. All right, but what this controller does, it's, now look at, let me give you an explanation, a very simple explanation of Kubernetes. So I wrote something on Twitter some days ago as well. I said Kubernetes has this autopilot feel. When people talk about Kubernetes, people can go to sleep when they have a Kubernetes cluster. Why? Because Kubernetes regulates itself. Kubernetes, when you put autopilot, if you watch movies a lot and you see autopilot, the pilot can just put autopilot and it's probably taking coffee, and the plane is just going on its own. It's regulating itself, it's doing things by itself and all of these things. So that's what the controller looks like. Okay, before I go ahead, I see Okwe is raising his hand. Yeah, Okwe.
Yeah, I just wanted to shed a bit light on that controller part. So,
okay,
as you've rightly said, it's controller manager, but what is it managing? It's basically managed. There are a lot of controllers in Kubernetes, and it's just like it houses all of them. It manages all of them. So you ask, what are the controllers in Kubernetes? Now, I would say 1 or 2 controllers. So, for example, if your we haven't talked about them yet, but I want to make reference to some of the things that happen in Kubernetes. So when you deploy something into a Kubernetes cluster, your application, basically they live in pod. As you can see pod 1, pod 2, pod 3, pod 1, pod 2. So let's say, for example, now something happened to the container that is inside of your pod, and it now dies. What Kubernetes will do is it will restart that container. So one thing is responsible for that, and it's like the pod manager, pod control manager inside of the controller manager. Another thing that can happen is when your node, this worker 1, worker 2, now they're basically your servers that your pods are in, that your pod lives inside. So let's say one node dies, the Kubernetes control manager will try to restart the node again. So there are a lot of things that happen automatically inside of the Kubernetes cluster like that, and they are all managed by the controller manager. So there are a lot of controllers inside of Kubernetes that they do different things. These are just few, So so that's what the controller manager actually does, and that's what he's trying to explain by autopilot. That's what it does. Like, it just knows that something is happening, let me do this thing. Something is happening, let me do this thing by myself. So that's it.
Makes sense. Thank you for clarifying that. And now the official explanation of a controller. So like Opeyemi said, it is supposed to be controller manager, all right? Not just controller, because controllers, we have a lot of controllers in Kubernetes. And let me give you what the official documentation explains controller as. Say you have a room that is hot, and you want to regulate the temperature of that room. Now, normally the way I explained it, okay, because I took the explanation for that, I said you get an air conditioner, all right, and you turn on the air conditioner and it cools the room. But when the temperature of the environment is reducing, that means when it's getting cooler, for instance, in the evening, what you do is you probably turn off your AC. All right. So that's manual. That's a lot of manual work. But this controller here, it's like a thermostat, all right, that regulates itself. So when your room is hot, it will try to cool it or try to take it to the temperature that you have set. When it is cold, it will try to, it will just try and change the temperature based on what you have already pre-configured. So you would have given a desired temperature, and you'd have said, this is temperature that I want my room to be, to remain on maybe 15 degrees all through the day. So when it's hot outside and the temperature outside is 30, the thermostat is reducing that temperature, to make sure it is 15 degrees like you have specified. Now, when it's cold at night, maybe like 14 degrees, the thermostat will say, okay, let me take it up. Do you understand? So that's what the controller does in your Kubernetes environment. And like Okwe said, when you have an application, for instance, you want to have maybe multiple copies. Let's say 5 copies of your Node.js. Let me show you this diagram again. Yep. So say you want to have, let's say 3 copies of this Node.js application. All right. Just assume these are microservices. You want to have 3 copies. Now, because your application can crash. Of course, we know that even before Kubernetes came, applications have been crashing. So you want to have 3 copies at every single time. Let's assume it crashes. Now, even you don't need to be awake. All right. Once you've specified to Kubernetes that I want to always have 3 copies, Kubernetes checks, all right, and it checks, am I having 3 copies in this cluster? If no, it will go ahead and create a new one. All right. So that's like the autopilot thing. If you say you want to have 2, it will ensure that it's always 2. If you say you want to have 1, it will keep trying to ensure that the actual state becomes the desired state. All right. So that's what a controller does. All right. But like we said earlier, there are different controllers because there are different parts of a Kubernetes cluster. All right. So that's for this master, which is the control plane, like we said earlier on. Now moving to this data plane where you have workers. All right. So now this worker 1. So Kubernetes, remember we said Kubernetes is an orchestration tool. All right. There's an orchestra and there are different people, there are different musicians in that orchestra team. All right. And so now in Kubernetes, typically you have a cluster of computers, a cluster of servers. All right. You can have one server that's running Kubernetes. It will work well in development mode. But one of the things that we have learned in software development is not to have one thing. All right. Don't have one thing. Always have, because if you have one thing running, for instance, you have one version of your application running on one server. All right. If the server crashes, your application is gone with the server. Do you understand? So we always have backups or we always have replication. So in Kubernetes, you typically don't want to have just one server. You want to have more than one server that is running your application or your workloads, like Deepak called it. So what you do is you have, for instance, in this picture, it says worker 1, worker 2. You can call those 2 different servers. All right. Now, in those servers, in Kubernetes terminology, they're called nodes. All right. I'll share a document. And when we read that book that I shared on Slack, we'll see all of these things. Okay. So these workers are called nodes. All right, they're computers, they're normal computers or servers, like you call them. But now, remember we talked about containers that help you package your entire application. So in these workers, you have something called the kubelet. This one here, kubelet. And what the kubelet is responsible for is for creating containers, actually. But now, in Kubernetes, you don't just create a container. What you create is a pod. A pod contains one container, at least one container. All right. So you have a pod, which is your application. But that pod now can have different things. Now, the reason why we have the pod, why we have pods in Kubernetes is because pod helps you communicate. If you are traditional Docker, all right, on your computer, and you are running 2 containers, you have to do a lot of work to ensure that those containers are communicating with each other, all right? But all of these things, the container networking and all of those things have been abstracted by Kubernetes for you, all right? So you have a pod, and the container knows that every pod can communicate with each other, all right? So a container that is inside a pod can communicate with another container that is inside a separate pod, all right? So just know that what you have in Kubernetes is, instead of containers, we call them pods, all right? So that's what you have. And those pods are running on your servers, which are called your workers, okay? So let me ask this question. Let's see if it makes any sense. So we said that you're going to interact with your Kubernetes cluster. From all interactions come from one point. Can we remember that point from this diagram? How do I interact with a cluster, with a Kubernetes cluster? Does anybody just want to just what is it? Somebody say something.
API. I think this is Omar Ijoma.
Okay. Yeah.
Okay, the API server.
Yeah, exactly. So you're communicating and doing all your communications via the API server. And remember, I also said that now when you tell the Kubernetes cluster that you want to deploy an app, you want to deploy Node.js in your cluster, a Node.js application in your cluster, the Kubernetes API server doesn't do it on its own. It communicates with something else. Can anybody remember? The API server communicates with something else before that app is deployed. Can anybody remember? Anybody? I want to just get feedback to see if.
Sorry, please, can you repeat your question?
Okay, yep. I said, so when you tell the Kubernetes API server that you want to deploy this Node.js, this is my lovely shiny Node.js app. I want to deploy it into this cluster. All right. What you do is you tell the Kubernetes API server. All right. But the API server doesn't say, oh, I take the app and I deploy it directly. It communicates with another component.
Scheduler.
Yeah, exactly. It communicates with the scheduler. So now what the scheduler does is it looks for, it checks, there's an algorithm, all right, whatever algorithm it's using, that's another story. But it checks based on its algorithm, where do I deploy this app? Now you have more than one worker or more than one node on this data plane, all right? So it checks, where do I deploy this app? Should I put it on worker 1? Should I put it on worker 2? All right, based on its algorithm. For instance, the algorithm can say deploy it on any free system, anyone. So it just does it randomly. So it just picks anyone at random. All right, or it could say check if this server has 3 gigs of RAM. Check if it has, if its CPU is at this capacity. It could be any algorithm. So that's what the scheduler does. It checks. Then when the scheduler checks the entire data plane and sees that, okay, worker 1 is perfect for your Node.js app, then it gives an instruction to the Kubernetes API server again and says, okay, this is where this will be deployed. All right, remember we said all communications go through the API server. So it returns the response back to the Kubernetes API. Then the Kubernetes API goes into the worker, this worker 1, and says, okay, now you have to deploy this Node.js app. But now the worker is just a server. All right, it's the kubelet that is responsible for now creating that container or that pod on this worker. So that kubelet now says, oh, I've gotten an instruction that I should create the Node.js app, or I should deploy it on my server. Then it does that. So if you notice, we have kubelet on each of the worker nodes here. All right. So now in software terminology, or in engineering terminology, it's called daemon set. Yeah, but let's ignore that for now. So the kubelet now says, okay, let's create this application on this worker 1 or on this worker 2 if it's worker 2 that was scheduled for. All right, so that's what this system does. Then you now have the kube proxy. All right, now I don't know if anybody wants to say something about kube proxy, maybe Tipo or Gideon or where you want to say something about kube proxy, just very briefly. Or let me go ahead. I don't want to be the only one speaking. Right, so because of time, let me just go ahead. So kube proxy helps with networking in the entire cluster. All right, so how does this thing talk with this thing? How does this one talk with this one? How does this one connect to this one? All right, so that networking aspect, that networking thing.
Okay. Let me come in.
All right.
So let's look at. I mean, I suppose everyone that is in this class is somewhat have the somewhat worked with containers before, Docker containers. So when you're working with Docker containers and you want to interact with more than one container, that means you will use what do you call it, Docker.
Docker
What's this other
Compose.
Docker stuff? Docker Compose. So you use Docker Compose. In Docker Compose, you do what? You define a network, and that network might be bridge, and it might be bridge, might be anything. And then in that network, you give it a name. And in each of the sections of your containers, you will give it a certain network to be used. So this container would use this network, and that means they can use localhost. When you define that in your container code, you can use localhost at a certain port to reach out. Say for example, now you have a web server, you have a database, and that database is running on 5432. That's Postgres port, and 5432. And now it is running on that port. Now, inside of your web server, you have said your application should connect to your database at this port in this local, because when you were developing on your system, on your system now, you have your Postgres running, you have your web server running on your system, and then you've already said localhost at port this. So before your coming from your system to container now, there's something that have to connect there, and that's the network that you've already defined in your Docker Compose. Now, the same thing when it comes to Kubernetes, this kube proxy, it creates a platform where each of the pods, we already said that these pods are like they are like a house for container, and the normal thing is the pod will carry a container, but there are cases where a pod will carry more than one container, rare cases. But basically, your pod is your container. Now, these pods can talk to these pods in the same server, in the same worker. But how are they able to do that? It is done by this kube proxy. It's set a baseline for networking communication between one pod to another, and that's what it does in each nodes. And it was talking something around daemon sets the other time. So let's say you have here in this picture now, you have 2 worker nodes. Let's say you now have like 5 worker nodes, 10 worker nodes. That means this kubelet and this kube proxy, they will be repeated in those nodes. It will make sure that they are being created in every node that are joining the Kubernetes cluster. So that's what they do.
Yeah, great explanation. Thank you for that. I hope that was clear to everybody. All right. So kube proxy networking within your cluster. All right. Port-to-port communication, and even okay. Now I said something earlier on. I said your interactions with the cluster, all right, is through the kube API server. But now when you deploy your application is also in the cluster. All right. But how do I now access my application? Okay, normally when you deploy your application, maybe you deploy it on example.com, all right, and that's how do you access this application? Do you have to go through the API server? The API server goes into the worker and checks and all of those things? No, not exactly. All right, so accessing your application is different from that interaction we spoke about. It's the kube proxy that helps you, gives access, external access, for instance, to that container, to that application. so that when you do example.com, it goes into maybe pod 1 and it picks up your application and displays it to the person. All right. So networking is solved by kubeproxy. So this is Kubernetes. This is the architecture. There's a lot of things that we can still discuss, further, but this is how Kubernetes works. Remember, it's one system, all right, but there are several components that make up this system. Not everything, and I think it's a beautiful design, all right, because it's not like if you have ever developed a monolith system before, one thing is depending on one thing and everything is just depending on each other. And if one thing breaks, man, or if you want to remove one thing, every other thing will crash. But in Kubernetes, you can have different, because these things are separate components, you can remove one and replace it with another one. For instance, you don't have to use, not everybody has to use the same kubeproxy component. All right. Now it's kubeproxy, but under the kubeproxy, there are some things that are making it run. All right. So we don't have to use the same networking solution. I don't have to use the same networking solution as you, but I know that I need a networking solution in my system. So I can replace one thing with another thing. All right. My scheduler, I don't have to use the same algorithm that somebody else is in their system. Right. So Kubernetes is a very big, and I've heard about some other Kubernetes solutions that do not use etcd. I've heard of something that uses SQLite. All right. So Kubernetes, there's K3s, which is also a variant of Kubernetes. It's a lighter version of Kubernetes. It uses something different. All right. So that's how the cluster is. Then one more thing, that's how the Kubernetes architecture is. So one more thing. Now you can remember, so you want to interact with your cluster. You have to interact with the API server. But what do you use to interact with it? Remember client-server architecture, all right? For those who are engineers, so we should understand client-server architecture. A brief explanation of that is, so say you have an API, all right? The API is your API server, basically. So what we call server, many times, at the time I was also confused. I used to call server, the hardware, the physical hardware. And you're not wrong if you call that the server. All right, your computer is localhost. The DigitalOcean server is the server. You're not wrong, right? But also later when I found out that the client-server architecture is not just the physical hardware. All right, the server itself is your application, your backend, what we call your backend. That's your server. That's why you have the Kube API server. Yeah. All right. So in the client-server architecture, there is a client that is making a request to the server. In this case, let me give you an example. You build a Node.js app or a Python app. You want to communicate with that server, that app. What you do is you take Postman, for instance, and you send a request, a GET request or a PUT request or a POST request. So Postman is like your client that is interacting with your server. All right. So in this case, how do you interact with your API? Do you use Postman? Yes, you can use Postman because it's a software, it's an application server as well. You can use Postman, but typically, all right, what you want to, because now you can use Postman because it's an API. All right, you can get the HTTP endpoints and send a request and it will work fine. But typically in the Kubernetes ecosystem, we use a command line tool called kubectl. All right, this thing here beside this client, kubectl. All right, so you can either use kubectl, you can use an API. You can connect with an API. For instance, you can connect from your Node.js application or your Golang application with Kubernetes. It's possible, all right? Or you can also use a dashboard like a GUI, just like you build your Node.js application, then you build a dashboard for it or a front end for it. So you can use any of these things to connect to your cluster, all right? So that's what Kubernetes looks like. I know it's probably confusing for some people because I've not heard some people say anything, right? But really, Kubernetes is a very beautiful technology, and it's like I said the other time, it's taking over a lot of things. There are other competitions to Kubernetes. For instance, there's something called Docker Swarm. There's something called Mesos, Apache Mesos, and there are other competition to Kubernetes. But Kubernetes has outshined all of these systems, and Kubernetes is very popular. So recently I was watching the documentary on Kubernetes. All right, there's a documentary that showed how Kubernetes started. All right, how they built Kubernetes, why they built Kubernetes, and all of those things. And in that documentary, I saw that Google built. They wanted to, Google was in this. There was this cloud rave back at the time when Kubernetes was developed. I think it was 2013 or so. I'm not too sure. If I'm wrong, please correct me. So, but at that time, when Kubernetes was developed, right, why they went about that was Google was thinking of how to come into this cloud market and gain some market share. All right. And they were looking at what to build. At the time, AWS was, the rave. There was S3 and all of those things. But Kubernetes said, Google guys, they already had something internal, which is called Borg. All right. Kubernetes was built from that system called Borg, and they wanted to take market share. So they said, let's build something that will help people, with the cloud, or help people in that cloud thing. All right. So they now brought out Kubernetes. In fact, the naming, one of the hardest things in computer science is naming. How do you name things? So they were thinking of what to name it, and somebody just said, okay, let's just call it Kubernetes, because Kubernetes is a Greek word, all right, that means a helmsman or a pilot, all right. So just the way you have a pilot that is controlling a plane or flying a plane, or you have a helmsman that is riding a ship, all right. That's why if you look at the logo of Kubernetes, you see that. Let me just quickly share my screen. Yeah, so if you can see my screen again, look at this logo of Kubernetes. It looks like a steering for a ship. Can you see my screen? I don't know if I can even see it, sir. Okay, but if you look at the logo of Kubernetes, it looks like a screen, a steering rather. So Kubernetes was taken from that Greek word to mean helmsman or pilot or controller, something that is helping or directing the flow of things, basically. So when these guys developed Kubernetes, you can have a look at the Honeypot documentary on YouTube. I will share the link afterwards. But so they now built something, because it was Google that developed it initially, right? And they open sourced it in 2014 at Docker conference, the first Docker conference. At that time, Docker was a startup, 1 year old, and they were shining, and everybody was like, wow, containers. Containers had been before Docker came, but Docker made it popular. All right. So everybody was happy at Docker. Docker had, gained traction in the community and all of those things. And Kubernetes built on top of Docker. If there was no Docker, we probably would not have had Kubernetes. Then Kubernetes came to that conference and they announced that they are releasing Kubernetes. And according to the documentary, I wrote some things on Twitter. You can check it out about all of these things that I'm saying. So what I'm saying, I've written it on Twitter. So those at the conference, it was like Kubernetes came to steal the show, because everybody was just saying, oh, Docker, 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 Docker. Now you brought Kubernetes, all right? And along the line, Kubernetes grew so big, at a particular time, Docker Swarm was the solution that Docker brought for what Kubernetes is doing for container orchestration. They said that Docker Swarm, the number of commits on Docker Swarm reduced to 0 at a particular week when Kubernetes was launched, because Kubernetes just came and captured the minds of people. And since that time, Kubernetes has been growing. It was because of Kubernetes that the CNCF was, came about, because Google said, oh, we cannot bring out this open source system in our name, because everybody will say, this belongs to Google. The competitors will say, this is for Google. So Google will have their interest in it. So they developed this Cloud Native Computing Foundation. All right. That's where they now donated it to. So Google and some other companies, Red Hat, IBM, and all of those big companies, they came together and they formed CNCF, and they donated Kubernetes to CNCF. So right now, Kubernetes is a project under CNCF. All right. I think it's the very first, because it was because of Kubernetes that they created CNCF. And CNCF over time has seen technologies. Remember, I said Kubernetes is a platform for platforms. All right, so CNCF over time has gotten people to donate projects. All right, we have a lot of projects under CNCF, and there are different stages for those products. Kubernetes is graduated. All right, it's no longer a so there are different stages. I think there's the incubation stage. So when somebody applies to donate a project that is cloud native compliant, and they donate it, it goes into an incubation stage, and it goes into another stage before it gets into the graduation stage where it's fully mature. All right. So Kubernetes started this thing, and CNCF has grown so big. We are currently running on CNCF, like the Get Going with Kubernetes Slack workspace. We're using CNCF, and it has grown so big. So if you want to get more information about Kubernetes, there is the Kubernetes website, all right, documentation or official documentation sites where you can just go there and just get as much information as you want. All right, the information that you need about Kubernetes will be there first. The release of Kubernetes versions will be here first. You know, everything that you want, the partners, the community, the case studies, everything is on this website. So everybody that makes a tutorial on Kubernetes, they will read this website first before they now begin to explain to you. All right, and there's the repository. It's open to everybody. It's open source. You can also contribute. Like I said earlier, I was using in Golang. All right, and so that's the official website. Then what else do I have? So I said questions. This is my final slide. I know we've gone beyond, so I'll just pause here because I think I like talking. All right, especially about tech. So do we have questions? Does anybody have any question? Anybody?
Yes, I do. Can you hear me? So I'm still a bit confused, right? Okay.
Yeah.
Opera me talk about services, right? And so if like a microservice or have like let me say 4 microservices running on
Mm.
different servers. I'm not so sure. I don't. Can you just explain the flow of from like deploying a microservice and using the Kubernetes just maybe quickly because of time and other people?
Okay. All right. I think that was Tipo. It was Tipo that spoke about microservice. So I
Okay.
don't
Oh,
think,
deeper. Oh, okay.
so I don't know if Tipo wants to talk or Ope wants to talk, but I can talk as well.
Okay.
Can I understand the question?
Go on, please.
Okay. You're asking what the process is of deploying microservices on Kubernetes. Right?
And sorry, how to like make there are different services and they can be deployed in different servers. So how to you still have to do you need to join everything at the end or they still like
To communicate
stay
with
on
each other.
their own? How do they like how the Kubernetes mix
Okay.
everything together? Yeah.
All right. So number one thing I want to correct from what you said is we're not deploying them on multiple servers. You're deploying them on just one. So the idea, like I said, is we have just do you understand the concept of VMs? How VMs work? Virtual machines.
Yes, I do.
So I'm guessing like maybe the usual that you might be used to is you deploy one application per virtual machine. Yeah?
Yeah.
Okay, so what we're doing, what for Kubernetes, what it does is we are going to be deploying all of them on one server or one VM. You can auto scale, but I don't want to go into a lot of details. But the idea is you're deploying the container. So one thing I need to talk about is first of all is that containers are really small in comparison to virtual machine. So if I'm going to say, oh, I want to deploy a virtual machine now, I'm probably going to be going a gig, 2 gig in memory. It's just deploy, right? But for containers, it can be as good as I still deployed something that was a Linux application that was about 50 MB yesterday. So there's enough space for you to deploy applications in just one VM. So back to your question of how we deploy. So the workflow. Let me just explain the workflow for you. Now let's assume we have 4 services, right? What we are doing is we are going to be writing the Docker file. and that Docker file is going to be used to create a Docker image. So each of those services will have a Docker image that you're going to be pushing to there's something called a container repository. So for example, there's Docker Hub. On AWS, there's ECR, that's Elastic Container Registry. It's the same way, maybe it's the same way you deploy your code now to GitHub or something. You are pushing your images, the image you built on your local system, you are pushing it to a repository somewhere. It could be Docker, or it could be ECR, it could be on Google, it could be on Azure Container Registry, anywhere. Now, those images are already in the cloud. How does Kubernetes use them? So the way Kubernetes uses them is pretty much, there's something called a YAML file. We call it yet another markup language for. Yeah. A YAML file is used for configuring how your application is deployed and how it communicates on Kubernetes. So for example, you take one of those yourself, one of the services you've created, you say, oh, let me call this service an auth service. I create a pod for it. So I don't want to really explain in depth, but what you're doing is you're creating a YAML file. So the way you deploy that YAML file is you use your kubectl. Like I think Ilaria explained that already, using the kubelet. So the kubectl is just like is a command line. What's it called? That's the application now.
So, hello.
Yeah.
Diko, please. The question, I want to understand the question. Are you asking the difference between microservice and Kubernetes, or how they both relate? Because
I'm asking like how they both relate, like the deployment process using
the deployment process of deploying microservices on Kubernetes.
Yes.
That's what I'm explaining. So the YAML file, when you use kubectl, is a command line tool that you use, that you install on your laptop and say, oh, kubectl apply to your Kubernetes cluster. That's another thing. I don't want to explain that. I don't want to go in depth into that. What that does is it takes your images, the images that are being deployed on your cloud repository somewhere.
Sorry, hold on, sorry. So it's the YAML file is going to like take all the images of the different microservices on Docker Hub.
Yes, it's going to look at it. It's a specification file. I don't know if Larry can drop a link on how it works. It's the same thing. Are you familiar with what's it called? JavaScript config file. What's it called again? I can't remember the name.
JSON.
Yeah. So you have some specification that you write out to specify the version of the JavaScript application, whatever. Everything, the location, some of the commands that you need to do, right? That's almost the same way the YAML file works. So things like the name of the pod, the image the pod is going to be running on, and a few other things, right? So that's what you do the same. You do that thing for all of your services. That's one. That's what deploys the pod. Now there's another specification file.
Sorry, wait, hold on. Let me just. So what you're saying is for the first services, right? They'll have 4 different pods according to my YAML configuration.
So for each of the pods you're creating, there will be a different YAML configuration file for them.
Okay.
Yes. Now when you deploy, your pod is up and running and all that, but you still also need to create there's something called services in Kubernetes. I believe there will be other sessions right today on how to do all of this.
Yeah.
So those services are going to be connected to each of those pods, and you can access them on your local system, right? I think the next session, Leo will explain. Is a lot that is going on. Like you might not really grasp what's going on completely by me just explaining. But when we do like a demo, you will have an idea of how all of this is connected and how it makes everything a lot easier. But pretty much what you're doing is you're creating an image, you're pushing that image out, you're creating a YAML file with all the specification that you need on how all the services connect to each other, or communicate with each other, and how you can also access them on your local system or on the internet, for example. And then you can access your workloads that you deploy. But it's a whole lot. I know it's a whole lot, but that's just like a simple or basic workflow of how you deploy your workloads on Kubernetes. I hope
Yeah.
that helps.
Yeah. Can I just
Yeah,
come in?
thank you.
Okay, Gideon wants to say something else.
Okay, yeah. So about the question about where your whether number of servers, maybe 4 servers or wherever your workload gets deployed on, right? That's usually at the prerogative of the scheduler, right? Now this scheduler, it's quite intelligent, right? So when it basically when you send a command to the API server that I want to schedule or I want to deploy an application, so it looks at the app, right? So oftentimes in that YAML file, sometimes you specify the amount of memory that application will need. So that scheduler takes information from that and shops around. It goes through the different servers, right? Which server has enough space or the enough resources to host this application, right? So the scheduler it's a very intelligent tool that does a lot of that. So the scheduler just goes through the different servers. So it's very possible that all your workload could be on one server. It's possible that your workload will be on 2, 3, 1,000 servers. It doesn't matter. It's the scheduler that makes that decision, right? And so and of course your scheduler is still customizable, and even largely you can still determine where your application gets scheduled, because that's even one of the most beautiful things about Kubernetes. From the ground up, almost everything is customizable. So if you don't, I don't want the scheduler to make this decision for me. I want to decide where my application goes to. All well and good. You can configure that and you can customize it. So the scheduler is really in charge of scheduling pods, and it makes decisions based on the resources available. So I just wanted to just add to that.
IJ, did it make things clearer or more
No, it's a bit clearer, but I know like along the line everything will make more sense.
Yeah, sure.
Yeah.
When you see it in practice, it will make a lot of sense.
Okay.
So I would say also that you should, get that book. I think it's on the Slack workspace, on Slack channel. Just go through the book, start reading it. Many of these things that we have said, you'll come across it and it will make more sense. And of course, we'll touch on them as we go further. We'll see it in practice.
Okay.
Yeah. So just like I said, you'll get it to be clearer as we go ahead, especially when you see it in practice. It will make a lot of sense. And yeah, like we said also, please feel free to ask your questions on Slack. I'll get Deepo and Gideon to join Slack as well. All right, so we'll be there. Just ask your questions and read the book as well. The book will help. The book has helped me. Like you said, I'm still reading I'm not done with the book yet. All right, but I'm still reading the book, and there's some things I never paid attention to that the book has opened my eyes to seeing. For instance, as simple as labels in Kubernetes. It should shock you that there's actually an SRE case for having labels. All right, and I began to think about it in AWS that, oh, that's why we have labels in AWS. And so the book will just open your eyes to a lot of things. So please read the book, read documentation, and ask your questions. Remember, I said that we're having workshops, we're having book reading, and we're having peer collaboration. So please get on that. I hope this has been great for all of us. Joseph, do you want to say what it's meant for? All right, even as a product manager, at least you should have an idea of what tools your team is using, why they're using that, and you should be able to contribute as well. So thank you for coming. Thank you for joining. Thank you, IJ, for staying till the end. Yeah, we'll have this session again next week, but it depends on us whenever we decide. So we'll put another poll on Slack, and whenever it's comfortable.
Thank you very much. I really loved it.
Yeah, glad to hear.
Okay.
All right,
Thank you,
thank you,
Gideon.
Yeri, Ndope, and Tiko.
Yeah.
with your
Um,
energy.
thank you, Akwe. Thank you, people.
Everyone.
Bye.
All right. Take care, guys.
Okay, bye.
Bye.
Okay.